Okay, so let's go on a little aside first about mixed numbers. They come up a lot in our work, so I might as well just get them out of the way right now. So let me look at something like this, the fraction 5 over 2, 5/2. Now people might call this an improper fraction because I have a numerator that's bigger than a denominator. People call those improper fractions, though there's actually nothing improper about them. They're perfectly fine fractions, nothing wrong with them. But let me work this out nonetheless. So it's 5 pies, 1, 2, 3, 4, 5, for 2 students. Here they are, 2 students. How many pies per student does that yield? All right, well I can actually see this one right away. I'm going to give this student 2 pies. I can give that student 2 pies, so each student gets at least 2 pies. That's fine. But there's one extra pie that still has to be divided between the 2 students. So I guess each student gets half a pie as well. So the fraction 5/2 is really 2 pies plus half a pie. Bingo, done. I can see it. Now a lot of people actually get lazy at this point. They say, don't bother writing the plus sign. Just get it out of the way, squish the 2 answers together, and write that instead. Which is curious because how you read that is still with the plus sign. People say 2 and a half. I just had the plus sign, and a half. But people tend to write that when you have a whole number and a fraction. They don't bother writing the plus sign, squish it together, and call that a mixed number. That's all it is. Just a little bit of a I don't know, efficiency in typing. No plus signs needed. Great, a mixed number, a whole number and a fractional part. As another example, let's work out, I don't know, say 16/3. Let's do that improper fraction. Work it out as a mixed number, 16/3, 16 pies for 3 students. So there'll be 3 students, and I'm going to share 16 pies equally among them and try to figure out how much pie per student that yields. Actually, let me think my way through this a bit. 16 pies to go equally amongst those 3 students. Well, I can give them each 1, then I give them each 2, I give them each 3, 4, 5, gets me up to 15 pies, but there's an extra pie floating around. Hopefully I'm still on the screen. Maybe, hope so. I can now see, oh, if I do it this way, each individual student gets 5 pies for sure, and this pie at the very top, but you have to still be divided amongst the 3 of them. They must get 5 1/3 pies. 16/3 is 5 1/3. Oh, except you don't write the plus sign. If you write it as a mixed number, just squish those together, 5 1/3. There's the mixed number. Great, great. Most people insist that everything be nice and logical, but technically this is also a mixed number. 7 and 11 are fifths. Most people don't like it, but actually technically that's a mixed number. There's nothing wrong with it mathematically, just might be considered weird. This would be a mixed number, 4 and -2/3. Most people like these to be positive numbers, but actually technically that's fine. You could actually make sense of that as well if you wanted to. Anyway, grand. Okay, so mixed numbers is a whole number followed by a fractional part with the plus sign removed. Grand. What I do need to do is just go through some very basic arithmetic of these things because it'll come up later on. Might as well get it out of the way now, make it easy for ourselves, and just think our way through it at this point. For example, suppose I want to do, say, 2 times 2 1/2. Well, the key about these things is to realize, well, there's meant to be a plus sign in there. Actually, write it out. This is really 2 times 2 plus 1/2. Okay, now it's good, because now it looks like a rectangle being chopped up. This looks like the distributive rule. In fact, this will be 2 times 2 is a 4 plus 2 times 1/2, 2 times 1/2. The reason I like this one, because this looks just like belief number 5, well actually consequence number 5. I've got the bottom number 2, I'm multiplying by 2, what's left is the numerator. This is actually 4 plus 2 times 1/2 is 1. And bingo, it's 5. Double 2 1/2 is 5. There it is, I can see it. Let's do another one. Let's do, say, triple 5 1/3. That number 5 1/3 came up earlier, let's triple it. Triple 5 1/3, I can say, all right, there really should be a plus sign in there. Helps to write it out. 3 times 5 plus 1/3. And what do I get? 3 times 5 is 15. Plus 3 times 1/3. 3 times 1/3. I'm in this situation again. Bingo, bingo. Must be the numerator. 15 plus 1 is 16. Beautiful, grand, and good. All right, so just remember, with mixed numbers, there's a really hidden plus sign. You can actually help to actually write that plus sign when you're doing the arithmetic with them.